Hello, and welcome to the Control Band. My name is Amy Stark. We have Jobert in the back, and today we're going to be talking about anticipation, recognition, and control. With anticipation, it's one of the most powerful ideas in professionals don't just react to problems, they predict them. And the earlier you identify a hazard, the easier it is to control. So, we find that most accidents follow a predictable path. The hazard exists, the exposure occurs, the controls fail, and the incident happens. With reactive safety, we focus on step 4, the incident happens. An employee is injured, and now we have a workman's comp claim, now we have lost work time, now we have placed on restricted duty. And so that's reacting to the issue. Proactive safety focuses on step 1, recognizing and anticipating the hazard. So the earlier you intervene, the lower the cost. You're reducing the lost work time. You're reducing the workman's comp insurance claim. You're reducing the human impact. You're improving employee morale, because nobody likes to see their coworkers hurt. And so we look to see where the hazards hide. Hazards exist everywhere work occurs. We have common categories of hazards, like physical hazards. There's noise, heat, radiation. We have chemical hazards, such as solvents, dusts, or fumes. Fumes being metal particulates in the air, not smelly chemicals. Just want to clarify that. That's what I mean when I say fumes. We have biological hazards, so zoonotic diseases such as Lyme disease from insects and vermin. We have bacteria, mold, viruses. We have ergonomic hazards such as repetitive motion, awkward posture, heavy lifting. And then there are safety hazards such as moving machinery, falls, and confined spaces. And so anticipation means asking, what could go wrong here? The analogy I like to use is that as a safety professional, you are essentially turning into the lawyer in the Addams Family. An old movie. I'm dating myself. But anyway, hear me out. The lawyer in the Addams Family, he comes in, he sees the way the family is interacting with their lifestyle. And he thinks to himself, boy, so many things could go wrong here. So many people could get hurt based on the activities that they're doing. And as a safety professional, that's your job. Your job is to come in and be the lawyer from the Addams Family and say, what could go wrong if something fails? What could go wrong even if something doesn't fail? What could go wrong just as a matter of course? A lot of times I see folks who they accept the hazard and the risk because they're just used to it. They have been working with this hazard for so long that it's become a part of their everyday work life. And so there are tools that you can use to anticipate hazards. A really common one is job hazard analysis. A job hazard analysis is breaking down a task step by step and identifying hazards at each stage. So let's take an example, a really simple example of washing dishes. First off, you plug the sink. Then you fill the sink with water. Then you add soap to the water. Then you fill the sink with more water to create the suds. Then you wash the dishes and you scrub them with the soap sponge and you put them in the dryer. That's breaking down a task step by step. If we look at the hazards, fairly low risk activity, but there's the hazard of spraying water outside of the sink and creating a slip, trip, and fall hazard through a wet floor. There is, if you drop a dish, there's the hazard of a broken dish and picking up shards of ceramic or glass, and the cutting hazard. It is if you drain the sink and a spoon drops down the sink into the garbage disposal, there's the risk of reaching in the garbage disposal for the spoon. I don't know about you, garbage disposals freak me out. And so I always double and triple check to make sure that nobody is anywhere near the switch for a garbage disposal, because I'm a horror movie fanatic. I've seen too many horror movies about what a garbage disposal can do to a human hand, and I do not want that in my house. But that's a job hazard analysis. Next is a process hazard analysis. So a process hazard analysis is usually used in chemical and energy system or industries to identify system level risks. So this could be, for instance, process safety management. When you have a highly industrialized work environment that uses anhydrous ammonia, identifying the risks through how the process of anhydrous ammonia is used. There is walkthrough surveys. This one's a personal favorite of mine, and this is where you conduct the observational assessment of the workplace. I love doing workplace walkthrough surveys. It is the best way for me to get an idea of what is actually going on in the workplace. I can look at paper all day long, but actually seeing the task at hand really helps me evaluate it. And then you have design reviews. And so design reviews are where you anticipate the hazard before the equipment or the process is built. This is where you can do things like build machine guarding into a new machinery. Because the earlier a hazard is identified, the cheaper and easier it is to fix. Machine guarding, light curtains, those are all much, much cheaper than the cost of an injury from an amputation from unguarded machinery. Next, never underestimate the power of worker knowledge. Like I said, workers know the hazards already. They are working with this task day in and day out, and so they know the hazards are there oftentimes, but they have accepted it for various reasons sometimes because they've been working with it for so long. Or you may have a new worker come in who just doesn't feel comfortable reporting the hazard because everybody else has accepted it, so why shouldn't they accept it? A really good example is workplace violence in nursing. Workplace violence in nursing oftentimes is an accepted hazard because nurses feel they should just deal with it. It's a part of the job. But really, there are things that you can do to mitigate the hazard of workplace violence from patients. And so encouraging reporting of these issues really requires building trust and environment of psychological safety and also visible follow through. When a worker sees hazards corrected, then reporting of hazards increases. And so you may run into a situation where you encourage reporting of hazards in the workplace, and then you find that all of a sudden there are hazards being reported everywhere. Don't freak out. It is not an indication that all of a sudden your workplace has become more dangerous. It is just that you have built that trust and built that psychological safety, and the workers have seen that you've done visible follow through. And so now they feel comfortable reporting those issues that they had before. And so the increase in reporting means that you're doing your job well. So that's anticipation. It's the first step in controlling risk because every hazard follows a timeline. You have creation of the hazard, exposure to the hazard, and consequence. And the earlier you act, the safer everybody becomes. So now we'll go into recognizing and evaluating risk like a professional. With recognition of risk, not every hazard carries the same risk. Some exposures are minor and others can be catastrophic. And now we'll talk about how professionals prioritize hazards. So first, a couple definitions. A hazard is something capable of causing harm. For instance, the person doing residential roofing, repairing a roof after a hailstorm, the hazard is falling off of the roof. The risk is the probability and severity of harm occurring. So you take that worker and say they're wearing their personal fall protection system. Well, then the risk of falls becomes extremely low because they're wearing, well, lower, because they're wearing something to prevent them from hitting the ground. There are things that would eliminate the hazard, such as putting up a barrier that would prevent them from falling, or fall protection in a manner that would keep them from encountering the edge of the roof, and so that would reduce the risk even further. But ultimately, you have to do a risk evaluation to help determine where to act first. So exposure matters, and risk depends on exposure. There was a gentleman in the 16th century, Paracelsus, who came up with this concept of the dose determines the poison. So risk depends on key factors such as concentration, duration, frequency, and number of workers exposed. And the dose determines the poison is an important concept because what it means is essentially everything at some level is poisonous, is harmful. That's concentration. If we think about water, people can overhydrate. They can poison themselves with water. It's a very high concentration. It takes a very high concentration to poison yourself with water, but it is possible. And then on the other hand, you have chemicals such as methylene chloride, also called dichloromethane or DCM. That is a known carcinogen at very low levels. So you evaluate the risk of water versus DCM, you're going to raise your risk evaluation of DCM a little bit higher than your risk of adverse health effects from water. Another key factor is duration. How long is somebody exposed to the chemical? So, or the hazard. For instance, I entered into a work environment without a respirator for a short period of time, and I got a nosebleed from an acute exposure. The duration was short, but the concentration was high. And so that resulted in an acute adverse health effect that resulted in a nosebleed. Another important factor is frequency. How often are folks entering this environment? Going back to the roofers, if you have residential roofers who are performing roofing repair work every single day for 8 to 10 hours a day, then that's going to increase the risk. Again, and also number of workers exposed. If you have 5 workers on a roof, that risk is going to be different than if you have 20 workers on a roof. And with safety, evaluating risk is often a matter of taking measurements, taking numbers. As an industrial hygienist, you can gather numbers and have concrete data through information or through activities such as air sampling, noise dosimeters, or heat stress monitors. These help quantify the risk. However, sometimes you don't always have a means to quantify risk. Sometimes you have to use your best judgment, and that comes with research and experience. When I was going through my master's program, my professors would often tell me that industrial hygiene is often as much an art as it is a science, because sometimes you don't have those quantification, you don't have those numbers to evaluate the risks. Sometimes you just have to use your best judgment. And so in order to use your best judgment, a lot of times many organizations use risk matrices. And a risk matrix combines probability with severity. They evaluate, say, probability of a incident occurring. Could be low, medium, or high. And the severity of the risk could be low, moderate, severe. And you take those, you plug them into a table, and then you categorize the probability and the severity. So low probability, low severity often equates to a category of low risk, whereas a high probability, severe health risk or severe safe risk of injury may combine into a category of critical. And so you have categories like low, medium, high, and critical. And this allows you to prioritize or triage your events or your risks and say, okay, we've identified this is a critical risk, this is a high risk. We're going to give these a higher priority attention versus our low and medium risks. The reason that we do risk matrices to evaluate um, tasks is because resources are always limited. Unfortunately, as a safety and health professional, you are going to eventually run into a situation where you have to justify the safety and health actions that you want to take because sometimes it's just not in the budget. And so you may have to justify why it should be in the budget by saying, okay, yes, it is expensive to install a light curtain on this piece of equipment. However, by installing a light curtain, we're preventing amputation injuries. By preventing amputation injuries, we are preventing lost work time. We're preventing possible loss of an employee. We're preventing retraining employees to replace that lost employee. We're preventing lost worker morale. We are preventing workers' insurance claims. And we are, in fact, possibly reducing our workers' insurance cost or workers' comp cost by proving that we have this control in place. That's just an example of a justification that you may have to use in order to justify spending more in the short term to prevent increased costs in the long term. That is an important factor of risk evaluation. And so ultimately, risk evaluation helps focus efforts on hazards with the greatest potential harm. Greatest potential harm may be an element of how many workers are infected, even if it's a small risk, because a small risk affecting many workers may be just as important as a severe risk affecting one. We go back to that pyramid where we talk about the 10,000 near misses is the eventual indicator of one fatality. And so by identifying those 10,000 near misses or those 10,000 small risks, you are potentially preventing a severe risk. In essence, recognizing risk is about understanding what hazards matter most right now. So once our risks are prioritized, we can move on to the most important step of all, which is controlling them. So if anticipation and identifies the hazards and evaluation measures the risk, then control eliminates the danger. So now I'll go into the hierarchy of controls. This is upside down pyramid time. The hierarchy of controls are 5 elements. And from most effective to least, they are elimination, substitution, engineering, keep my hand on fame, elimination, substitution, engineering, administrative, PPE. The closer you are to elimination, the stronger the protection. The reason being, these controls are arranged in this manner because what they're essentially doing is they're taking control of the hazard away from the worker and placing it into something that reduces human error. Let's take an example of Dichloromethane, DCM, methylene chloride. I work with folks who use DCM to clean glass. And so if we look at the hierarchy of controls, the most effective method of reducing the risk to the employee from this known carcinogen would be to remove it from the workplace and eliminate the whole process of cleaning glass with solvents altogether. That would reduce the risk or eliminate the risk of exposure to solvents. And so that's the most protective method. The next most protective method is substitution. If we could substitute another solvent, such as methylethyl ketone, for dichloromethane, then we're drastically reducing the risk because we are taking a known carcinogen out of the workplace and substituting it for something that we know is less hazardous. Engineering controls is the next step. So exposure to DCM is controlled in this situation through a ventilation system. This ventilation system is installed and evaluated periodically, and it operates automatically, so the worker doesn't have to worry about turning it on, and it reduces human error by taking control of the situation, and it places the responsibility for control on a piece of machinery rather than in the employee's hands. Next is administrative controls. So in this case, a chemical hygiene plan, because this is a laboratory environment. So with a chemical hygiene plan, what we are looking at is we are looking at housekeeping and general handling of the chemical. We're training employees on the hazards of the chemical, how to protect themselves, and what protections and controls are in place. This is educating the employee on understanding the risk. This is a very important part of administrative controls. And then we have PPE, or personal protective equipment. This places the most responsibility on the employee, and so it is the least effective because it introduces human error. In this case, the employees wear gloves. Before I came into this workplace, they were using nitrile gloves for handling DCM. If you're familiar with how nitrile gloves act around solvents, you would know that this is not an appropriate glove material to use. And so what I did was I basically gave them better gloves to use. The sacrifice that they had to make was that they lost a little bit of dexterity because the gloves are now thicker, but it is reducing that skin exposure to DCM. Now, again, human error, human factor, sometimes I'll walk in and they'll be using nitrile gloves, and I have to re-educate them that nitrile gloves are not appropriate because they don't actually protect you. And they'll say, yeah, I know, when I spill it on my hand, I get a little bit of a burning sensation. And I'm like, yes, you will, because nitrile gloves are not appropriate. So placing the responsibility for controlling the hazard on the employee really is not the most effective way to control something. And that's why we have a hierarchy of controls. Some more examples of engineering controls are things like machine guards, the light curtains that I mentioned before, ventilation, noise enclosures. An example of an administrative control is rotating work. So if you have an ergonomic hazard from assembling something on a conveyor belt, and they're sitting on the right side of the conveyor belt, constantly using their right hand, you can say, okay, halfway through the shift, we're going to switch sides. So we're going to put you on the left side of the conveyor belt. So now you're using your left hand to perform the motion. So you're rotating the work. Now, when it comes to PPE, PPE is still important. You still need PPE. But as I mentioned, it is the weakest in the hierarchy because it depends on knowing how to make the correct selection. So again, those employees using nitrile gloves versus different material gloves for use with DCM. Correct use, making sure that folks are actually wearing it, such as that instance where I entered into a controlled environment without a respirator. Correct maintenance, making sure that folks are cleaning it and maintaining it so that it isn't degrading or getting dry rot. And human compliance, again, making sure that you're actually wearing it. So, whenever possible, you should always control the hazards using elimination, then substitution, then engineering, and then administrative, finally PPE. However, strong safety systems will combine multiple controls. Like I said, with the chemical exposure to DCM in the workplace where we are now, we use engineering controls, administrative controls, and PPE to control the hazard. And so this layered approach will dramatically reduce the risk to the employee. So, in conclusion, controls transform safety from theory into protection, but even the best controls will fail without one critical element, and that is the safety culture. We covered anticipation, recognition, and evaluation, and controls. So, next we'll go over safety culture. But in the meantime, I want to thank you for joining me for this episode of the Control Band, joining me and Jawbird up there, and look forward to seeing you next time. Thank you so much.